can I make it more somewhat how it like, let me make it a marker here to make it very dotted, to make it better, to give you more understanding. So this is the cap thing, because the as why I am capping this thing at 1, because in logistic regression we work on the probabilities basically. Okay, how much probability, 0 to, generally probabilities between the 0 to 1, you can see in that format. Okay, let me change the color here. Okay, and let me make it let me see, is it edge is possible or not here? Not this one exactly. Make it so. So logistic regression generally used for binary classification, where we use sigmoid function, that is this thing basically, and that takes as input as an independent variable and produces a probability value between 0 and 1. That what I show here in the sigmoid function basically. Okay, but let's focus on some of the key categorical point, or you can say some key points. So logistic regression predicts the output of the categorical dependent variable. What is the meaning of it, we will talk about when we go in depth of it basically, and it can either 0 or 1, something like that basically. Okay, now sigmoid function is taken, but then basic ones into another value with range of 0 and 1. Okay, the value of logistic regression must be 0 and 1, which cannot go beyond, because the point which shows the S form, that if you're kind of you getting a sigmoid function, it's called S basically, right? So, but what are the types of and what are the type of logistic regression we will talk about? So let's go into that. Basically, what do, and I will write types of logistic regression. Okay, and let me make it something like kind of bigger and make it like this. Okay, and let me make it, there are 3 type of it obviously. One, okay, let me make it a delete point for now, and around it basically. And as you see, that's a major focus behind is this function basically, right? Now, when we see, let's understand this graph more better, I guess. Okay, so let me get into it. So if you will see here, if you will very see here, there can be two possibility, right? Let me go to my pen part. Basically, this is kind of very two part. One is this sigma of z, 1 minus sigma of z. What is the meaning of it? Let's understand better. Or let me go like let's. Okay, I am saying if there is any function of f of x, right, and which has two things. One is sigma of z. That is sigma of z, where basically means how I tell sigmoid function. Basically, sigma means sigmoid. Basically, you can say, and 1 minus z. Really sorry, I don't know why it's happening. 1 minus sigmoid of z. Now, what are the, you can say, what are the major parameters that we are right now focusing on, right? That's a major thing behind it. Okay, but so let's suppose if, or before getting into it, or before getting into the function, why I'm getting this thing, let's understand the whole function. Like the, really sorry why it's happening in this format. Let me, sigma of z is equal to 1 plus, sorry, 1 plus e to the power minus z. That's a basic function, right? Suppose z tends to 0, e to the power 0, that is 1. So it is 1 plus 1. It is 1 by 2 is equal to 0.5, which is approximately 0, you can say. Okay. Now let's understand if z tends to infinity, which means limit z tends to infinity of this function upon 1 plus e to the power minus. So e to the power n, well, if this is power of infinity, it will be factor 1, right? If e tends to Cool, let me then that way. Okay, cool. Okay, let me start. I guess you ended the last stream, I guess, but okay, cool, no worries. Take it later. But yeah, so now this one basically we will basically give you more. Just give me a moment, folks. Let me sort it out this thing. Okay. Okay, let me. So before getting into this thing, basically, around it basically. So just give me a moment. Okay. So let's understand if I will take or like, okay. So X is basically where passing like independent feature vector, you can say. Yeah, input feature, you can say. Okay. And let me get it like why it is still in this thing. Let me x23. Okay, and something like dot 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 dot. This kind of input, or you can say thing. X is an independent variable, and Y is a dependent variable basically, which we get Y is okay with which will give you 0 or 1. Okay. Okay, which is like 0 maybe if the class 1 and if class 2 basically something like that. And generally what we are doing here basically, cool, let me if it is like very doing that thing, let me turn off my cam, then it will be better, I guess. Okay, so let me do that, I guess. Cool. So the z, if I am taking as a function, which is something like summation of I will do 1 to n, where y of I upon x of I plus bias. That's the basic thing behind it. Okay, and you can make it like a bracket, something like this, that we are doing something like this. Okay, and what we can do for this thing, something like this, you can make it as a as I already created xi as a for the matrices and all. For you can make it like w dot capital X plus b, where w is equal to wi plus wi2, something like that, like plus w2 w3, something like that basically. Okay, this is the basic logistic regression, that how we are working around it. Okay, now as we talk about sigmoid function and all, okay, so this is a kind of ratio of px upon 1 minus, we are just taking a ratio out of it. Okay, 1 minus p of x, because what we are saying, like if I talk about or like make it more better, let me, okay, let us understand p of y is equal to 1. Okay, okay, p, which is give you sigma of z. Okay, and if p of y equal to 0, that means we are getting, so it's something like 1 minus sigma of z, right? Now let us understand, when we say sigma of z, just we have to put it here, right? Sigma of z is equal to 1 upon 1 plus e to the power minus z. Okay, let me take a ratio of p of x. upon 1 minus p of x, which is something like same only, which give you p to the power x. That's a basically taking a ratio out of, and it is kind of getting you the same, something like that, right? That's the major focus behind it. Okay. What we can do here, let's take this equation as equation 1. Let's adding log on both side, adding log on both, logarithmetic of both sides, so it will something like log of p of x upon 1 minus p of x. Let's make it 1 minus, okay, or really sorry, not this, 1 minus p of x, okay, and it will become x because it's log e to the power x, so it will become x, okay. Let's split this thing, so it will something like log of px minus log of 1 minus or plus log of px, which is equal to x. You can say log 1 can be 0, so it will be nullify some for a moment, I guess. That's the case that we are doing here basically, okay, right? And really sorry, okay, this way. Now my point came here is, what is z actually at this moment, okay? So z actually here is e to the power w cross x plus p, right? This is the thing that we are seeing actually, right? So when you basically do the whole mathematics and all, it will come something like e w t x plus p divided by 1 plus e w x plus p, which is something like 1 plus e to the power minus z, thing. Okay. Now let's find out the loss of this whole function, right? We created a model and let's find out the loss. So loss will be something like loss of this is y cap comma y, that is y predicted or minus y actual, right? That's the basic thing behind this, how we find out the thing. Or do we make it more better, I guess, because we are using here w and b, so we take a weight and bias. So w and b, okay. Where I'm multiplying the thing, what I'm multiplying, so let's do this thing. I, the probability of x of I by I of p of, or not to be p of actually, let's to multiply 1 minus p of xi 1 minus yi, okay. Let us take a log on both sides, you can say, okay. It will something like log ly comma p, ly p when you're applying log, so multiplication become you can say summation obviously, so it will something like summation of p of xi yi into 1 minus p of basically, so how I make it like it more in that term basically, the xi, okay, and 1 minus y, this is the whole log basically, okay, something like this. So it will be like summation of yi log so yi log of p of something like p of xi, this will become multiplication value plus, so and again the summation of log of not this 1 minus as usual format yi something like this and log of p of xi. Okay, so if you basically if you will see here, if you will basically directly do an implementation part of it, it's something give you something like this output. I'm not sure. You will do the more mathematics part. I'm not getting into it, and it's kind of give you something like summation of minus log of 1, okay, plus e to the power z, that is mhm, okay, z you can say plus summation of y w dot x like that. Okay, so this will give you something like that. Okay, now the major question came here, like this is the thing that we got around it, and after that we will do differentiation of that part basically, and you get something out of it, and we can do it in that way basically. Okay, so this is the basic thing how it totally works around it. So I didn't take much, so obviously I didn't take much time around it. What we will do, just give me a moment. So obviously like I didn't take much time, and let's do some implementation part of it because I'm not taking so much time around it. So what I will do, let's go to collab. Okay, let me refresh it, I guess. I don't know why it's still lagging something like this, but yeah. So let's do a new notebook. I will take my fan off from here. Okay. Okay, so let me connect thing, I guess it is better. And let me make it this. So so firstly, I will give you how to implement a basic logistic regression. Okay, something like that. But before that, let me go to part. Okay, and I will create a new file. Maybe I will write it form of like just give me a moment. I have to create a file. I created some kind of data obviously. Okay, so give me more that. Let me add the file. It's just give me a moment. Okay, let me make it like customer data, something like that. So just give me a moment, folks. I guess let me edit this thing. Rename the file with this, I guess. And let me, what I can do here, maybe let me copy the data, I guess. I created a random data, so let me add this data here. Okay. Uh, Just give me a moment. Let me set up this thing better. Let me delete this thing from here. Like, um, let me do a normal command prompt basically. So if I will say in this format, let me. This is the kind of data. Okay, something like this. Okay, so well, let me do maybe a one thing. Let me do Siri or maybe LS for the better thing. Okay, we are in the sample data and we have to basically, obviously, so let's do one thing. Nano customer underscore data. Okay. Nano is not there. So what kind of let me take this bullshit off. And what I will do, let me delete this thing and maybe create from my side. Just give me a moment, folks. What I will do, I will do it from my customer point here. Let me do touch customer data.csv. Nano okay, really sorry. Customer underscore data. And let me paste this thing. And control N. And we get cool. I guess I got it. Let me upload this. I basically created a new file for you all. So let me add this thing here. Give me a moment, folks, till then. And those who don't know what I did, basically, let me change a window for you to give you more what I did actually. So you will get it. Okay. So basically, give me a moment. Let me push customer data here. So okay, if you will see, I basically added customer data here, and let me get you that customer data. Let me first of all, I guess you are seeing the my this part basically. So let me switch back to let me change my window to I guess this one. Okay, I basically uploaded that file only. So hopefully you will get what is okay. I guess I got why it is not showing CD sample. Okay. And let me do cat customer data CSV. I guess it will show you now. This is kind of very weird. Or maybe let me do this. Something like this. Okay, I guess you will getting this point, right? This is the thing. Basically, we did it. I added one data here. Okay, and now let's get into the thing. How we basically how we can build it from the scratch. But before getting scratch, basically, I will tell you how we can build it from. You can say how we can basically use SQL. There's a library called sklearn. Okay, we will try to explore that thing from sklearn actually. Let's do a very basic thing. So let's import pandas SPD. Okay. Now let me from you can say from sklearn. Okay. Obviously, I get it the sklearn dot. I guess I got it already, right? These are three things that I needed actually. Okay. Actually get it in more better way. But I guess I just got the train test split basically. Okay. But okay, let me do it. Okay, so this is thing we imported right now, but I guess right now we only need for now the train test split, so I'm not getting this basically. Okay, and we do data. If I will create a data from pd dot read csv. Okay, okay, and let me run this first of all. Okay. Okay, we will get something like this. If you want to basically if you want to do a plotting also, you can obviously do it. But what is this data is doing basically? If you will say this is the A, this is the cell, this is the credit score, and this is the purchase, right? This is the, on the credit score basis or the salary basis, we will basically doing like it will purchase that thing or not, like specific any specific thing. Okay, there's a major thing that so let's understand the my major basic thing. Okay, so let's do a work on the thing. As this is why, because this is the thing that we have to work on, like this should be predicted around that thing. So let's do one thing. So let's do x equal to data dot drop. Okay, we have to update our data with the thing called, or maybe let me copy this thing from here. That will be better. Copy and make it here. Okay, and maybe we can go to comma access equal to 1, which is means the right, something like this. And I guess it's predicted me the same thing. So what I'm doing on the axis part, that is the y. So this is the y basically. Axis equal to 1, I'm basically dropping that part. Okay, the axis equal to 1 to be considered as a column. If I'm axis equal to 0, that means row basically. I'm dropping that. And I created and added another thing y, and I'm trying to this thing with the splitted part. Let me complete this thing. Okay, I know it is giving you all the thing what I'm trying to say, but let's do that. Okay, so if you will see here, as I'm not implemented logistic regression till now, I am guessing, but let's implement the thing. I guess let me implement the whole thing. Then let me add another code here. Okay, as we imported like already model selection, like let's import from sklearn. Okay, so sklearn.dname or import logistic regression from metrics also accuracy score, because we have to find out the accuracy and maybe something confusion metrics, if that fits well basically. I guess confusion metrics also, and if it sounds good, so maybe classification report too. Okay, and okay, this is maybe for the okay, maybe make it like as SNS, like it it already gave me the that part, so let me run this. Okay, we imported it right now, and let's do the find checking part of it. Okay, we are getting kind of accuracy constant, which is kind of good, okay, which is kind of good for us. But let's, as we just pass like model.fit to understand what is we are doing good, or like this have to be done on the like accuracy part. Is it good? Let's predict and with by prediction and all basically. Okay, now let's do some confusion, like what is can be the confusion matrix also. Let me write confusion. Okay, maybe let me write confusion matrix equal to is it already getting it? So let's let me let me do, or like can we do it more? This is kind of our confusion matrix, if you will say, like 2011, something like that. You can say in that way. Or maybe if I will just write maybe not okay, delete this now and let me add a code and just write conf matrix. So something like it in that way only basically. See, it doesn't make a sense obviously, but I'm just showing you around it. Let me delete. Okay, and let's do some maybe let's do some maybe classification report basically to get you more understand. So let me do class underscore report is equal to classification. Like it is already predicting that thing. Basically, what I'm doing, I'm just passing by test and by prediction basically, which I actually did it. Let me run this. Okay, it will give you a proper what is the precision recall F1 score. These are kind of, you can say, the score that it's like really kind of give you report about the precision and all basically. I'm not going into the everything what is the main precision recall and F1 score kind of thing. Okay, let's do a heat map of it. That is already is the power of like generative AI, you can say basically. Okay, and this is you kind of you get basically. So now this is what we got from the whole thing about this data is doing or good. It is showing it is kind of 75% where it's false true, false negative kind of thing. You will see in that way. Okay. Now let's try to implement the thing like in a more from scratch way. How we try to implement this thing from scratch. This is the thing we just like using calling a function and try to do it. But let's do something from scratch. Maybe not from the thing of you can say. I will do it from very class like oops concept basically. How we can do it is something like that. Okay, this is what we do it. And suppose so. Let's get started. So let me do in the bottom down. Maybe I will add a text here, and we will write scratch implementation of logistic regression. Okay, let me make it better, I guess, from this thing. I guess this is kind of good. Okay, it's kind of good, I guess. Okay, so let me delete this part of this. Cool. So let's firstly import numpy, which is obviously important. Import numpy is np. Okay, and let me run this obviously. Okay, now write class logistic maybe logistic regression from scratch, like not scratch obviously, but yeah, as it already even though why, like I have to, otherwise I have to, yep, in it where we are passing self variable, obviously learning that iteration part basically, which is already showing you here basically. Okay, and where I'm passing self dot learning rate. Okay, learning rate equal to obviously learning rate, and like same thing like iteration weight and biases basically. And this basically for now I'm just basically making it none value basically, weight and bias, because obviously it's doing nothing. This is a kind of constructor. Okay, this is kind of constructor for you. Let me do one thing for you maybe here. This is constructor thing. Okay, we built it out constructor. Now let's go into the next part. Okay, now let's build a sigmoid function. That is the main thing, right? Sigmoid self.x, like simple, like this is basically what, this is what you can say 1 divided by 1 plus e to the power minus z, in that way. Okay, I'm really sorry. Okay, so this is the function that we built. This is a sigmoid function obviously. Okay, if you will see here. Now next part. Okay, next part is let's initialize a parameter. Okay, so let me create, this is a function by the way. I'm really sorry. Why? Initialize the parameter. Okay, where we are passing obviously self comma sorry, self comma n obviously. Okay, obviously from self dot is equal to np dot zeros. Okay, with n comma 1. So it is like we are providing the shape actually to that. Okay, that's the basic thing. Okay, and cell dot b equal to 0. Okay, now let's do a propagation part then. Okay, here we initialize a parameter like w and b, basically weight and bias. Okay, now let's propagate. That means again with you can say self x comma y. Okay, now let's do slope. That is m is equal to x dot shape of 1. Okay, now let's do maybe let's do forward um, forward propagation. Let's do forward propagation. So for that basically what we have to do, let's take a is equal to this self dot so here basically we do self dot sigmoid as we are using for the function, right? This is a sigmoid function that we created here. Okay, now then we pass np dot, that's the formula of that basically, you can see. Okay, something like this. and close this thing. So till now, this is the kind of activation function you can say. Let me do it in this way. Okay. Now this part is the cost function part basically. If you will see here, the cost function. Okay. This is the whole thing of forward propagation. Okay. Now let's do backward propagation. Backward propagation. Okay. Which like obviously give you the weight and bias dB and dW. The same thing. I'm doing the same like np dot dot. So this is kind of formula only. Like if you will see here, like okay, sigma function, and this is the cost that we we have to find out. Okay. Now let's understand the cost now. It's something like this, and we have to return this thing. Okay. Now this is something. This is the propagation part that we did. Okay. Now let's do fit function basically. Okay. Let's do fit function basically. Okay. Same self x comma y basically. Okay. Let's initialize the parameter with self dot initialize. Let me see what it came around it. Let's initialize a parameter here for okay, and start shape. Okay, and like what I'm doing here, let me show you. Okay, so here is a loop where we iterating. There's the fit function again and again, iterating again and again with the gradient that we got, the cost function we got basically. Okay, we are kind of propagating. Now let's retrieve the derivatives from the gradients. Okay. So let me retrieve it basically. Okay. Or like make it like just give me a moment. So before going into this thing basically obviously, and what I will do, let's do or like this is more like retrieve derivatives from grads, that means gradients. Okay, and let's do dw. I guess you get it. No, this. So I am upgrading with the basically with the same retrieve from the grads basically. Okay, and here I am updating it. Okay, if you will see here with weight and bias, I'm updating the learning rate. Like this is you will gotten something like how I will explain you this. This is a gradient descent actually. This is a gradient descent formula actually. This part is gradient descent formula actually. Okay, by what I'm applying for it. Okay, and if, suppose if you want to, and again the next part is basically here. Let's record the cost. Let's see the cost part basically. How what we are getting actually. Okay, so cost of iteration of this thing basically of I comma cost, you can obviously do it obviously. Okay, now there's a fit function around it, and okay, so I guess I'm out of the loop. Okay, self dot we are params, I guess. Okay, with this. Okay, or make it more like how I can say in this format. Let's do the grads also obviously. Self dot grads is equal to dw comma dv, okay, and cell dot cost, cell dot yes, we didn't have to do something like that. And let's do the recent part is the prediction part, what I'm doing it by prediction, okay, by prediction cell dot sigmoid, or like let me make it more better, I guess, for you all, so it will give you more sense. So slope is equal to x dot shape, okay, width of obviously, and the prediction of np dot 0 we have basically propagate on the size shape of the that part basically, and okay, but we are want to predict it, right? We obviously take the weight and bias around it and something like that, but we have to add a something like, you can say, let me make it yeah, you can obviously do it in this way obviously, okay, then you will do a loop basically, which basically transit in that way, okay, in the shape of like, okay, by prediction and all. And let's do the accuracy part now. This is the basic function behind it, okay, if it is more than 0.5 and if it is less than 0.5, that's the thing basically, okay. So let's write a function on accuracy, okay, and not this, basically we have to pass the parameter self comma y true and y predict, okay. So we have to pass, and again that's the same thing, but let me directly return with the direct formula, you can say. So 100 minus np dot mean, okay, np dot abs by true mine, sorry, by with by prediction minus y true, okay, and into 100, sorry, I guess y 100, okay. Let me just run this first of all for that. So this is the class that we created. This is the whole logistic regression thing that we did, okay. Now let's do some implementation out of it. Let's do some example kind of it, okay. Let's do it. So let me write np dot random random dot seed for one obviously, okay, and let's do xtrain, okay. Maybe we'll pass some random thing basically, np dot random, okay, with 2 comma 100 maybe 2 comma 100, okay. If you want to know what actually this function is doing, just head over the function basically, and it generally basically tells you actually what is doing and something like that. It's a built-in function you will see, and like something like that. I'm not getting into the chart now. Y train, okay, where I'm passing np dot np array, kind of doing a vectorization here, you can see in that format basically, okay. And Okay, so 0.3 comma 0.7. Okay, okay, extrain, which is something like, or let me make it like, let me, I guess I wrote this, I guess, example somewhere in the code, I guess. So let me copy that thing from that example. Like that will give you a better understanding. Actually, just give me a moment. Okay, and let me make it right here. Okay, and let me do it. Okay, why it is showing this? Logistic regression takes no arguments. How it is possible? I guess this is the same function that we the copy, and I guess now it will take most probably. This is kind of weird. Let's see why it is happening in that format. I guess everything is going. Number of iteration. This is what we take, an iteration, right? This is the only thing that we want. Learning rate. Okay, I guess the thing is, like, okay, I guess I run this class already. Let me understand why it is happening. Let me normal run this thing maybe as a lost regression thing maybe. Okay, I guess it is kind of showing kind of good. But if you will see here, I already run this. I still don't understand why it is not taking, like, even though I passed in the form of that. Let me copy this thing. Why it is, let me see here. Maybe let me do one thing then. If this is the thing, let me copy this, and like if this is the, it will doesn't matter even that also, but let me try this. Still kind of same think around it. Even though we kind of built it overall from the scratch out of it, let me, okay, let me do one thing then. Okay. Okay, now I guess this is the main thing. Actually, this is a space that I found it out basically. So basically, what actually I did, I will explain that basically. So uh, actually, in init method, basically the class aspect learning rate as an argument. So like I didn't actually add it in there basically. That's the basic thing behind it. Okay. So if you will see, it is showing you the proper cost and around that what is the test and train accuracy. This is that we built from scratch. Okay. So I hope so you got what I wanted to tell you. I hope so you get what I'm actually what I did. If you didn't get it, at the actually here, this part, actually I not initialize it basically here. So that's why it's facing kind of like I'm not initialize anything here basically. So that's why it takes like without taking any input, and because it is empty in that moment, right? That's what the scene basically. I hope you get it. I will upload this whole code maybe after the event, but I hope you got it. Let me know if you're facing any issues, and let me stop streaming, or like let me know if there is any issue or anything regarding, or you not face it didn't get any point anywhere. Let me know. Is it everyone? Let me turn on my cam. I guess that will. Okay. I hope you got it. It takes me a lot of time to basically build from scratch. Like also is another a lot of it basically. But okay, I guess you get it. What I'm trying to show. It is. I want to let me show you about the SQLM thing basically. I will write logistic regression. This is the SQL library. Okay, let me open it for you. Okay, so this is the thing that we called and directly do it in that way. Okay, if you want to go to the source, just click on the source. Cool. So this is the thing. Try this thing also. Okay. So obviously you can try around it, and this is the way you can. This all doc string is there, and obviously I will upload that thing on our GitHub repo, so you can do it obviously. Yeah. I hope you got it, but yeah, this is the thing that we are doing. Cool. I guess let me stop stream. I don't think so. Is there any question till now? What I can do, let me share this collab link with the folks to get it more better, I guess. And just give me a moment. Let me share this thing with everyone. Let me do it. Okay, let me do it with everyone. Like they just, otherwise they can just view and around it basically. Okay, copy the link. And obviously I will add this to our GitHub repo basically, obviously. So do not take tension around it. Copy the link. Done. And yeah, Afzal, I guess you can stop streaming obviously. This is the link you can drop in the live chat section if possible. I just dropped in the collab link, and you can end after it, after dropping this link.